Science A, Unit 4, Iteration, Lesson 2, Algorithms with While Loops. Flag variables, which are variables that are used to indicate whether something has or has not yet happened, are extremely useful tools to use in loops and conditionals. At the beginning of the program, we initialize flag variables to a false value or 0 to indicate that the event we are looking for has not occurred. So here we have import java.util.scanner, and we've got a public class demo. And what we're going to do is we're going to read in input. We set our flag to 0 or false. And then we have num entered. We've got it declared. While the flag is false, set to 0, system.out.println, please enter a 5. And you leave it blank. Num entered is set to the keyboard.nextInt. If the num entered is 5, then you set the flag to 1. Otherwise, you're going to ask somebody to enter it again. Notice that the flag variable can be an int or a boolean or anything. It is a variable only known to the programmer. So you could just as easily have said up here that flag was boolean and it's set to false. And while not flag, then you could come through and then set flag to true. Both would work. Algorithms with loops. Suppose we wanted to check how many numbers a user entered to satisfy a condition. Every number entered is smaller than 10. We just need to use a count variable and increase this whenever the condition is met. So here we have our count is set to 0, num is set to 0. While number does not equal -1, we ask them to input a positive int or -1 to stop. Then the num is read in by the scanner. If the num is less than 10, we increment the count. Okay? And keeps on going. Now notice there's no error checking here, so somebody could have entered in -5 and it wouldn't be a positive integer, but that's okay. Count minus minus, here we're going to subtract 1. Why? Because if the number is less than 10, and up here notice -1 is less than 10, we're going to increment the count. So what we want to do is we want to throw that back out. We don't want to count -1 because that was our, hey, stop variable. Over here, notice if this line is reached, the loop is immediately ended. So int count is set to 0, num. While all of this is exactly the same, we get the integer. If the number is equal to -1, we break and we jump outside of the loop. Else, if count is less than 10, we increment the count. System.out.println, there are so many numbers. Everything's the same except we use this break. Now, break is not tested on the AP exam. It is also something that needs to be used with great care, okay? Because a break ends a loop right then, right there, and it might not tie up the loose ends. Breaks, if you use them too arbitrarily, can kind of cause a false narrative, if you will, in your program. It's sometimes much better to end it cleanly, okay? But a break is sometimes a useful way, especially in a short, quick program, to get out of a loop. Now, let's do some multiple choice practice. What is the value of sum after the following code is executed? Pause the video and figure it out. You're back. Okay, so P is 3, Q is 1, sum is 0. While P is less than or equal to 10, sum, okay, so we got sum out here, sum's going to be changing. Sum was 0, is set to sum plus P, so 0 plus 3 is 3, mod 1. What's the remainder? 0. And then you increment P and you increment Q. And you're going to keep going until P is 10. Okay? So does it change after the first one? No. How about, and notice you're always modding it by Q. So then you're going to make this 4, and Q becomes 2. Now, 0 plus 2 mod 2, still 0. Notice how it keeps going, okay? I walked you through this first one. And then through the second one, the next time around, P is 5, Q is 3. We do sum plus P, which is 5, and mod it by Q, which is now 3. And we wind up with 2. And so on. And we keep going until we wind up with 12. Here's the work if you stepped it through all the way. So your final answer should be C. Okay, again, here's the work. Each one of these shows it going through. Remember that this is mod. What is the remainder after? Okay. Now remember order of operations too. Okay. One of the things you got to remember, boop, 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 okay, is order of operations here. You're going to do the mod and then you're going to add. So 3 mod 1 is still 0. 4 mod 2 is 0. Okay? You're going to mod the P by the Q and then add the sum. All right? So again, it goes through. You got 3 and 1, 4 and 2, 5 and 3, 6 and 4. Okay? Oops. What is printed as a result of the following code? Num is set to 5, dum is set to 4. Well, num is greater than 4 and dum is less than 10, you're going to increment num and then make dum equal to num. And then you're going to output num with a hyphen between it and dum. So run through this loop and see what you get. Are you done? Did you get 10 and 10? You did 5 and 4, then 6 and 6, then 7 and 7. Notice right here, you're going to set dum the same as num when you come through this loop. There's no place else. Once you start coming through the loop, dum and num are going to be the same when they come out of the loop. So now it's just a matter of as long as num is greater than 4, which it stays, and dum is less than 10, you're going to wind up with 10 and 10. Fantastic. Try this one. What is printed as a result of the following code? Okay, if you need to pause the video, let's take a look. M starts out as 30 and N starts out as 80. They both satisfy the condition. You increment M by 15 and decrement N by 10 each time. So notice you're going up by 15 and down by 10 until either M is less than 200, okay, or while M is less than 200 and N is greater than 20. Well, it turns out that N is going to wind up going below 20 first. So you wind up with 120 and 20. Well done. And that ends lesson 2.